Hello, everybody. Welcome back to another session of From the Field. My name's Trevor Kennedy. I'm here today with Taz, who will introduce himself, Shabal, and Rajesh from THL Digital. Welcome to our stream. Today, we're going to talk a wee bit about the THL digital journey into the cloud, specifically moving a monolithic application to microservices. But before we get stuck into the technology, let's do a quick round of introduction. So myself, for those that are not a regular to the stream, Trevor Kennedy, I'm a principal architect here at AWS. I look after financial services mostly, but also our large enterprises around the globe. Taz, do you want to introduce yourself, mate?
Yeah, thanks, Trevor. Hey, gang. My name is Taz. I'm a solutions architect at AWS, and I had the pleasure of working with quite a variety of customers, ranging from startups through to sort of mid-market enterprise customers.
And we've got you here because you are
Yeah,
THL
sorry.
Digital's.
That's right. Yeah, so I've had the pleasure of working with THL Digital for quite a few years now, and helping them with their cloud journey. And hopefully, we've got quite a few interesting stories to share today, and take some learnings away for everyone.
Good stuff. Shabal, do you want to introduce yourself, mate?
Yep. Hi, Trevor. Hi, Taz. I'm Shabel. I'm a solution architect at THL. I've been with the company for around 2 years now, and happy to be here.
Good stuff. And Rajesh, do you want to introduce yourself, mate?
You're right, sorry, Rajesh. I'm enterprise architect at THL. I've been in this company for long enough. You don't have to know how long, quite some time. Been in the industry for quite some time as well. And glad to be here to share our story with everyone who is watching this.
Excellent. So yeah, one of the things that when we were setting this up, I had not heard of THL Digital before. Apart from Ted's talking about them within our internal meetings, but the stuff you guys do is pretty impressive. So I'm looking forward to you introducing the company, Rajesh. I think people will be blown away exactly what you guys do. A massive Kiwi success story, which is great to see. So I think what we'll do today is we're going to start with a bit of introduction so you can introduce the company to us and to the audience. And then we're going to get stuck into the technology, yeah? How we've managed to move a monolithic application to microservices. Does that sound like a plan?
Yep, wonderful.
Yep. Sounds
Good
good.
stuff. All right, let's start with the introduction then. So I'll throw your slides up here, Rajesh. It's
Cool,
all yours, mate.
wonderful. Yep, let's go. So THL is the world's largest commercial RV rental operator. So it's a tourism holdings limited, and you can see that we are in different part of the world. We are in the USA. You've got brands like Road Bear, Almonte. You've got Brits and Mighty. If you've seen around in New Zealand, these are the brand you will see on the road as a camper van moving around. We're in Australia as well, and then after that we've got UK. We've got Just Go there. We've got a couple of franchises in Japan and South Africa as well. As a company, we are global, but at the same time, we are local. We are a Kiwi company. Everything started here. So in Australia and New Zealand, we have got 35 years of history. In USA, we've got 50 years of history. And we are in 5 different continents. And keeping in mind, we are all over the place. We all connected with the one network. That's a THL. So it's a Kiwi company. Now, what exactly we do? So we build our camper van. So we are rental, which is the largest rental company in the world. But at the same time, we build our camper van through Action Manufacturing. And we have got a manufacturing plant in New Zealand, and we also got subsidiary assembly plant in Australia. Some of the specialized vehicle what we build is basically St. John's ambulance. That's built by Action Motor Bodies. We've also got New Zealand Police. These are the specialized vehicle we build. Then we have got New Zealand Defence. Also, we build a specialized vehicle for them. And Queensland, ambulance that was also built by by THL. And all these, what you see, specialized vehicle name behind that is basically Action. So that's another division of THL. That's what we build. So we build camper van, we rent camper van. Obviously, the next thing what is going to happen is basically we sell. So what we do is basically, we have got globally we sell around 2,000 vehicles annually from different sales division, and we basically RV camping and retail accessories as well. So when we sell these camper van, obviously our customer comes back to us and says that, hey, I need this specific thing for camper van. So we have got a really good online retail business, and we do really well on that. So we've got RV camping retail accessories business, which is in New Zealand, Australia. And then at the same time, because we're so specialized in the camper van, we have got servicing center specific for the camper van. So we have got in New Zealand, and we are expanding other part in New Zealand and Christchurch in Queenstown, and that is also you will see other part of the world as well. So it's a rent, build, and sell model. It's a pretty unique model.
So
Now,
just a question on that one before you move on, Rajesh.
Sure.
You guys, when you say you build, so presumably you don't actually build the camper van itself. You do the fit out for them. Is that right?
So technically, we get the engine from the manufacturer, and everything what you see on that engine, we put the whole thing. The what we call is a house on the engine is basically done by THL, and the manufacturing plant is in Albany, so you can go and see there. It's everything. It's a very unique experience to watch that, how exactly they build everything in the manufacturing line.
That's so cool. If someone had told me that we built camper vans and ambulances in New Zealand, I would have said that's rubbish. I've never heard of that. That's pretty cool.
That's amazing. So in this COVID time, the Exxon manufacturing, which is in Hamilton, and they have grown massively. So we are hiring. We're basically hiring every day, and we have got basically backlog for next 3 years. So we just can't take any more orders. So it's an amazing
That's a
story.
Great story, yeah.
Now, apart from this, rent, manufacture and sell, we also got a few very iconic tourism attractions. If you've been in New Zealand and you've seen Waitomo Caves, that's also basically managed by THL. Some of those brands you can see on the screen. Blackwater rafting, really cool. You can go for 3 hours and 5 hours blackwater rafting, and it's amazing. What they offer there. We've also got brand Kiwi Experiences, the green bus, what we call. In this COVID scenario, it's in hibernation state, but that's a very unique brand what THL offers. It's amazing. Now, this is all tourism. Now, at the same time, THL has done massive investment in a digital side. Now, some of the things what you see on the screen is basically THL, as part of THL Digital, they have built their own booking system, and that's a journey we'll be taking you through today. We have launched this booking system in Australia and New Zealand, and now we are basically working on to basically roll out globally, and that's a work in progress. In vehicle telematics device, we have got telematics device sitting in the vehicle. We basically grab data from there, and that's what will basically take you through the journey, what we do with those kind of data and what happens, and it's really cool. We've got investment in TripTech. If you've traveled in New Zealand, Australia, and basically ever downloaded CamperMate, it's a very popular app. That's basically done by TripTech, and we have got ownership in that, 60% joint venture. And RoadPass Digital, if you know Togo Group, today it's been renamed as rebranded as a RoadPass Digital, and we have got investment in that as well. At the same time, we have got a Camplify. We have got investment in that as well. If you've been watching news, THL has basically done a deal with Camplify. So it's a P2P camper van rental. It's like a peer-to-peer. It's like an Airbnb. If you've got a camper van, you can rent them through. So that's another digital technology. So that's basically digitally supported. Now, what is happening in COVID scenario? That's a very interesting story, because we are primarily in the tourism business, but what exactly happening? Because we are still growing. So what happened is basically we had to do a deep review of our business, because that's a COVID scenario everyone has to do, and being in tourism sector, with the degree of change in the organization and significant cost reduction, we needed to reassess the whole business. What we did, we basically questioned, had we missed anything? Had the focus on survival been at the expense of what we need for the future? So we have to basically look for, tourism has to come back, what exactly we are doing. So we had to basically really think about all those things. And we had to basically balance what is now and what is the future. And we came out with the conclusion that there are some activities we need to bring back, some we need to do differently, and some new things we need to do. So that's a business. As a business, we started thinking. We sold over 2,900 RVs throughout the world. So that's the different, when you go to rent, there is the demand for RV in the world, and we started selling those things. We buy and build well from both quality and value perspective. So we basically, that's a different model which is running in the background right now. We have developed reasonable domestic rental business within each of our regions. So now we've got a domestic rental as well. And we are operating as a specialist vehicle design. The Axon manufacturing, what you've seen, that business is making profit today. And that's basically balancing other part of the business as well. So that is doing, they are building specialized, vehicle, refrigerated truck bodies, and a whole lot of things happening right now. Now, we also basically done, it's a new part of the business. It's basically essential service providers using vans for mobile offices, because is a huge demand for that today. And then if you've seen around in New Zealand, we have got a vaccination van, which is moving around. So THL has given 80 vehicles to New Zealand government to basically be on the road. So it's basically helping the community to basically get vaccinated at the same time. And at the end, we also have one of the strongest balance sheet today that the THL had in the recent times, despite the current headwind and without raising equity during the pandemic. So it's a crazy time, but THL has got a really strong balance sheet. And the way it's able to do is basically moving around things and looking at different, part of the business and how it can grow in different areas. And that's how THL is so strong today.
Yeah, that's amazing. Being a tourism business, everybody would have thought COVID, you guys would be on the rocks. But to hear you're growing from strength to strength, that's brilliant, right?
That's right. So our journey. So what was where exactly we started, where we are today. So Monolithic to Microservices, and then waterfall to agile. That's we are waterfall company. Copy and paste to CI/CD. Every time I say, Chaval smiles. That's a common problem. We had a really old technology, so we had to basically refresh the technology. At the same time, we have to basically do innovation, because THL as a company, it was growing, and all these things we have to do to basically keep moving. So what we had before, it was a monolithic application, very simple application. We had a massive database server. As business was growing, this database server was growing. When I say database server, means this server was getting bigger and bigger, from 15 core to 18 core. It was just increasing every day. We had a IS web server, a couple of load balancer here, and then we had a B2B and B2C, which is for the customer. So it's a very simple structure, and it was working quite well. Now, obviously, this structure had a lot of advantages as well. So at the same time, it was very easy to deploy, which is easy development, fast development as well, easier testing. It's the one thing we have to test. It's very easy, easier error tracing, and trustworthiness. We knew that this is the application which works and it has to work. But at the same time, we had a lot of disadvantage with that application. So what was happening is basically development speed goes down as application grows. When we started growing our business, applications started growing, and then it started taking longer to develop. Scalability was the biggest issue, because I'll take you through some story. When we had a get moving campaign, everything got to hold because system just can't cope. Reliability was the issue. Lack of flexibility of the business growth. We just can't do things. It just it's a big monolithic application, and we all know encourages tight coupling between modules, easy to cause. We just create a bug. You try to do something, it just happens without knowing it. And it's not agile friendly, so you can't really do agile things in agile way, because you can't make small increment. Hard to deliver individual models, because every time you want to deliver something, deliver the whole thing. And when you want to deliver, there's a big fight goes on that who is going to check in and which code is going out and a whole lot of things. It's like a mission to basically get something out of the door. And massive deployment times. As your application starts growing, it takes longer to compile and deploy, and the whole thing basically gets stuck there, and which basically discourages the CI/CD. So challenges as business. What was happening when these things are happening as a monolithic application? Obviously, we're facing a lot of challenge. It was stopping us to grow the business. We changed from 8 to 10 hours business to 24/7 uptime because we just around all over the world. Slow to market. Anything we want to do, it was really slow to market. We had a big engineering team, but we just not able to deliver things. The application was growing. Old technology, things were failing. It was not secure. And the lack of innovation. We're not able to do all these things because we stuck with this monolithic application. We had security issues. We had a performance issues. This is the example I've given you. Get moving, campaign when we had everything was hold, and if you tried to book on the website, everything was stopped. We had a data governance issue. A lot of issues. And this is where we had to really think. And we were thinking, what's the solution? We're asking to ourselves, move to microservices? Answer was no. I don't think, just moving to microservices was the answer. So what exactly we had to do as a business? We had to really review our processes. So we had to think about what is our vision? What is our strategy as a digital strategy? So we had to basically focus on that and move forward from there. We had to look at our culture, how we do things, because that was the biggest factor when you want to move forward. We had to basically do things in an agile way. We had to review our technology stack. And then we have to also look at the data strategy, like where exactly, what we want to do, where we want to go from the data point of view, because we wanted to become a data-driven business. We wanted to do continuous delivery because, when you have got a system, you should be able to deploy. We are 24/7 business. We just can't say, hey guys, 10 o'clock in the night, we will shut down everything and deploy something. There's no such thing. If developers are working right now, they want to deploy right now. They want to test it right now. Everything should happen right now. Automation was the biggest issue for us. So we're not able to automate things. And then, we thought that all these things, how we can do with the scale of the business, scale of the application, we decided to move into microservices. So what happened? So when we started looking at our culture, we thought, okay, let's bring agile because this is the way we can move forward. We had to basically learn. We had to basically understand. We have to adapt. And we have to transform. And that's basically ingrained in the business today. So this is the way we work every day. We think about, we basically understand, and we basically transform. We basically did quite a lot of innovation, cloud services. We built really complex pricing. Really, it's really complex pricing structure. We invest in people. We basically give them training. We had two different batches basically going through the AWS training. So we basically work with a partner and give them training and go through the certification. And we basically recognize them, what they do, have they done the certification, help them, and basically give them time to basically work through that.
Just before you move on from there, so out of curiosity, how long did it take for that journey for you guys to go on that journey? Was it a 6-month process, an 18-month process?
So the review process was probably 6 to 7 months when we had to basically review everything, and the transformation when we turned from monolithic to finally going live with microservice application, and I'll show you the stack. It's a massive stack. That took close to 3 years to basically get there, and you will see why, because business is really complex, and we had to basically change the way we do everything in the business. So it was a huge effort. So why microservices? So easy to scale, and when we show you the microservice structure, what we'll take you through, you will understand how you can scale things. Can scale only specific models. We have got example where marketing basically goes and says that, hey, we have got a promo going on, and there's a watch out the news. There will be promo coming on. We've got the news, so there's something coming. So if something is coming, we have to scale things. So we have to scale pricing because this is where something's going to happen. You have to scale the booking services, so you can do specific thing there. Decoupling of services means lower risk. We can make changes in specific services, push it to live, and we are not going to interrupt other services. easier collaboration between dev, less risk of conflict because we don't fight now. We just say, hey, you're working on this service, go on, you merge your code and go live. Agile friendly can quickly deliver small changes by targeting specific microservices. So we can basically say, hey, that's a change, push it, other things are coming. Easier to secure different models, because these are different microservices. We can target the permission, different specific permission for the specific work, services. Ability to use different programming languages. We've got people, working at PHP, or people can do things in different ways. We basically, connect with a completely different services which is not even built by us, and the only way we can do is basically we're using microservices. Reduce deployment time, because now we deploy service, not a massive 1 terabyte application. So it's easier and fast to deploy. Typically, code is easier to understand because it's a smaller piece of code, so you can understand and reduce the scope. Now, when we had to build this, we had to obviously look for the partner. So we gone with AWS. And why AWS? So how exactly they're helping us? So provides all the tools we need to build a scalable product. So if you look at AWS, everything is there. Like, what you need, it's there. It's secure. We have heavily used IAM roles and security groups for each component, and that we can secure your components. Established and stable. They've been in the industry for a long time. I don't have to explain how long, but they've been here a long time, so they've been here. They've got really large online community groups. So if you've got any issues, you get stuck into problems, there is help. There are things there you can get help out of it. Provides tool to monitor, reduce cost. You can basically, if you're cost specific, you can basically put a alert on it. If it basically goes more than that, you get an alert on it. So you can monitor all those things, and there's a lot of monitoring tools you can basically monitor all this. Rapid prototyping. Today we don't have to basically think about, hey, can I have a server? I had an example, last week, and we had to basically build a server, Windows server. We don't use Windows Server around, so we had to build a Windows server, and that was just a simple step. We don't have to buy a server to do things. It's just ready within 5 minutes. So it just you can do things, and what we want to try didn't work. We just destroy the server. High availability, dozens of regions and availability zones. So there's all over the place. You can basically go different zone depending on what is the requirement from a business point of view.
Yeah, out of curiosity on that high availability one, and we do have a question in the chat, which I'll come to in a second. So for high availability, do you guys actually deploy in different regions around the globe to support the local users, or?
Not at this stage, but that's a plan we'll be getting to. So there's a discussion going on inside, and that's where we'll be going towards. So
okay,
we have got options available.
And the question in the chat is, you talked about the online AWS community. Do you have some guides there on which one's your favorite, or can you give some guidance to the viewers on which ones they might want to look at?
Chabal, do you have any preference there?
Not really. Usually I just Google stuff, and there's ton of them. Sometimes I have to go to Reddit. Sometimes it's on AWS documentation itself. Sometimes the majority of time it's on Stack Overflow. But yeah, so when you Google, you get a lot of options to check.
Yeah, I find that Stack Overflow is a place that I go to visit a lot. AWS Answers is a place I visit a lot, and even Git, right? Git has tons of code on there with samples of committing, being able to talk to our APIs or our SDKs, etc., etc.
And that's a great thing. Sometimes you just need a piece of code, and the majority of time you will just find it somewhere. So you don't have to create everything from scratch. The majority of time,
someone's already done it.
Somebody already did what you want, and you just take it from there and modify it.
Yeah, I also find that, personally, I think GitHub is excellent for that. I mean, there's lots of source code and also a lot of documentation and roadmaps available on GitHub. And the other things like dev.to and Medium, I think are great resources for us to use as developers as well.
Dev.to is really good. That's right. Yep.
Yeah, that's right. Yeah. I mean, there's always an article or a blog posted there, and kind of gives you a couple of shortcuts, right? Because problems are unique, but there's many different ways of solving them, and there's always good published materials available to us from the community.
What a lot of people don't know is internally at AWS, solution architects like myself and Taz, we have a KPI to produce content, and the easiest way for us to produce content is to put it on Git and then make it available to the community. So you'll find a lot of essentially AWS driven content on Git made available to the community. So always a good place to look at.
You should plug your repo there, Trevor. You know, if you got your GitHub alias.
My repo's a bit rubbish, but there's much better developers than me out there that work for AWS, that's for sure.
Okay, carrying on. So use AWS expertise. Taz is on the screen, and Trevor is here. These people just help you. If you need help, just call out for help, and they are there to basically help you. So what you do is basically, if you need expert, AWS there to help you, and you basically focus on what you do better, and that's a development, right? And leave complicated infrastructure. That's my last thing. I'm saying that that whatever maintenance, all these things, leave it to AWS. Allow your resource to focus on more complicated application development, and that's where our power is. That's what we can do better. Now, this is a really complex structure, and this is what we built, going from very simple monolithic application, which is a database server and a web server, few load balancer, and we got to this. So this is a microservices, and I'll basically point to Chaval. He gets really fascinated when he basically starts explaining this in a minute. And what happens is basically this is where the entry point is, basically when portal is there, and from there everything starts going down. So Chaval, I'll hand over to you. I won't basically steal your thing.
So before we dive deep into this one, can you just pop back to your original monolithic architecture? So I've got some questions about that, and then we can dive deep into the microservices one. So just to be clear, the one you've moved was from your booking system. Can you tell me a wee bit about the booking system? So this was allowing people to book what exactly?
That's right. So if you basically jump on our website, which is brits.co.nz or brits.com or mavi.co.nz, and you try to book your camper van holiday, and basically, so this is your B2C. So you basically go to mavi.co.nz or Mighty. You basically get from here, and this is the core booking engine which is supporting your website.
Gotcha. Okay, and so coming back from the you've got the consumer coming in via the internet. The first thing they hit is your firewall. So that's on-prem firewalls.
That's right.
Yeah, and then from your firewalls you had load balancers there. Again, on-prem load balancers.
That's right. Yep.
And so let's talk about the example you gave earlier on, where you have a big promotion. I'm assuming then those load balancers were purchased to be able to scale to these large promotions, as you guys knew that every Christmas you're going to have a large promotion, so your load balancers had to be big enough to be able to support that influx. Is that right?
That's right. So literally, if there's a big promotion going on, the whole team is basically sitting in the background to support this infrastructure. So we will be monitoring all our server, and we'll say, yep, that web server is hitting 100% now. Bring another server in the load balancer. So we'll have there's no auto scaling. So we'll have a 3 server to start with. And as the load increases, we'll just keep adding more and more server. And what happens is basically it's midnight, people are tired enough, we are tired, we go to sleep, we got a 20-yard server running overnight where there's no load on the server at all. So a lot of waste of resources, waste of money, but that's the way we should support this. And even on that, sometime when the load comes, you're too late in reacting to that. So it's all reaction, right? And so the whole thing goes wrong because there's a big load going on, everything is queuing up, everything is down now. So what you get is basically fail notification from all over the place.
So you don't have. Go ahead.
So I was just going to ask, and so you start with 3 and you scaled up to 20.
Yep.
That implies that those were virtual load balancers. So you guys just needed to have the hardware in the back end to be able to support those 20 virtual load balancers. Is that right?
That's right. That's right. So the problem what we had was this layer you can extend to 20, but problem what we found is basically all the time it was here, because this is you're running your 16 or 18 core, and that is what you can do. You can't basically extend anymore, because these servers are expensive, and every time you want to do anything on that level, you have to basically turn off thing and turn on, and there's a disruption to the whole business. So we used to start struggling on this level as well. So there was a different layer and different timing you start struggling with, and then
okay. So your web servers were virtual as well, or were they on physical kit?
No, it was a virtual.
Yeah, and your SQL server, virtual or physical?
It was a virtual.
Okay, so you did have the ability to be able to scale up as you needed. So if someone came to you, Rajesh, and said, "Hey, we need another 64 gig on the SQL server," you'd be able to do it because it was virtual.
That's right. We'll say that, okay, we'll basically schedule this for tomorrow 10 p.m. because this is when business goes down, and we can basically do that, restart the whole thing, and it's back to normal. So there's a disruption to business before you do that.
And also, I imagine, Rajesh, like you'd have different sort of scale types, right? So for your database, you had to scale up rather than out. And that's got the associated complexities, right? Like restarts and reconfiguration of the DBMS.
That was the biggest problem. Like every time you would basically, you want to scale, and you have to turn off whole thing, add more, CPUs, add more RAM, and then basically turn it on.
So out of curiosity, where was that capacity coming from? Is it most of the time it's sitting there idle, or did you take it from somewhere else from the business during those peak periods?
Depending on how we plan, sometimes we'll take the resources from the other running servers and basically use it for that promotions, and that was a biggest challenge, because you're taking away things from someone else, and they're going to suffer for some time.
Okay, and obviously this was all sitting on-prem. So do you guys actually have data centers somewhere that you run and operate, or are you just buying it from a third party?
We had a third party.
Okay, so at least then you could utilize extra capacity that they had as part of that third party, to scale up.
That's right. Yeah, and they also basically give you, there's an allocation for you, so you can only use up to that much. That's and so if you start using more than that, then you go to different pricing and a lot of things. So and you can't basically, when you've got a promotions like a get through New Zealand, you don't know the number, how many people are going to basically jump on the website and start booking. So, and these things takes time to basically do that. You can't basically auto scale thing here. Things has to happen. So you're basically watching the traffic coming. There is a 2,000 people sitting on the website, and things are basically crashing now. And you got to basically start turning off things, and then you bring it back. And by the time all those people is already disappointed, gone away. So it's a really, really interesting challenge to have. You have got a lot of customer, but at the same time you can't support them.
Sounds like the COVID vaccine passport website all over again.
That's right. And
way too soon.
I did manage to get mine today, so I've done well.
I didn't.
Give us some time.
And I was not surprised to hear that server is basically, application is basically built to handle 200 requests per second, and I said that sounds very familiar to me because that's what Q has done testing for, right? Anything more than that, I have got
it's
no
never going to test for it. Yeah, they're kind of the limit everybody goes through, right? It's like, right, let's test this in production. 200. That's where we could get to.
Right.
The other, so I'm also curious in what about backups and restores for this type of environment? What did that look like?
It's best thing is basically I started really old SQL servers. So in that case, when you take a backup, there's a downtime to server, a lot of things happen. But gradually it basically got better, so things can happen in the background. But you have to manage all those things on your own. And problems you find is basically backup failed because there was no hard disk space on the backup drive, so those things happen. So because you're managing everything on your own, and I still remember, backup used to fail quite a lot because your database is growing quite a lot, and then the backup drive what you allocated, that's running out of space, so the backup can't happen. And sometimes you realize after a couple of days, holy shit, backup was failing. So because you're managing everything on your own, that's a problem, and you can only allocate your resource on certain thing.
And disaster recovery, did you guys have a whole disaster
Yeah,
recovery standby?
That's what we did. Had a DR environment. It was completely in different infrastructure, and it was because the mirrored environment SQL Server basically gives you out of the box. It was a mirrored environment, and happy to say that we never tested that, which was great. But we had a DR environment, and look, I think it was complex to change. Like that's why we never tested, because we knew it'll work, and because when you start changing all this configuration, you have to make sure that all your applications, so everything's pointing to a different zone and different place. So, but we did have DR environment as well.
Okay, so and that kind of just basically just mirrored this current monolith that you had here.
Exactly. Yep.
In the same data center or with a separate provider?
It was a different infrastructure. So it was from the same provider, but in different area.
Okay, and then patching. So obviously in this environment, you guys are patching everything. I know that's a real painful exercise for most organizations, right? The whole monolith patching and securing.
Yeah, we had to basically keep the schedule to basically patch. So they will have a Excel document, and we'll basically keep track of which server is running which version, and then you basically go through, this week we are going to basically attack these servers, and the next week we'll attack these servers, and we are talking about hundreds of servers right now. So it has to run schedule, like you basically run this through 4 or 5 months to basically make sure. And again, while you're doing all these things, there's a disruption to business. You have to announce, make sure that business knows about it, and then you basically patch them. And because of all those restrictions, what happens is basically you start skipping your patching, and then your server is outdated. And then what happens is basically you are so far behind that now you're at a risk that if you upgrade from here to here, is your code is going to handle? Is things going to continue working? So you get into that scenario where you create massive risk for yourself, and then that's it's just because you want to continue your business.
Yeah, I used to work for an antivirus company as part of their threat research team, and one of the things I found really interesting is we used to run some underground forums for basically hackers, and the reason we ran them is because we wanted to see what everybody was talking about. So some of the bigger underground forums are actually run by this company I work for. What I found interesting is when Microsoft releases a patch, you get communities of hackers coming around the globe, coming together and trying to reverse engineer the patch. So what they look at is they look at what does the patch actually fix. Once they find the hole that fixes, then they start trying to create script to compromise the actual vulnerability. And essentially, between 24 and 72 hours maximum, they would have a solution to be able to take advantage of this vulnerability on the internet. And most of them were within that 24-hour window, right? So essentially within 24 hours of Microsoft releasing a patch or Red Hat releasing a patch, you got as soon as they release it, you got 24 hours to get your servers that are online patched, or there's going to be hackers out there that have the ability to take advantage of that vulnerability. And then it's just luck whether you get hit or someone else gets hit. And to your point, the longer you fall behind on that patching cycle, the more vulnerable the more likely you're going to get hit, right?
That's right.
Another interesting part of that research we did as part of that team, we put brand new servers on the internet. So servers that had never been seen before, we put them on the internet with our monitoring software and saw how long it took before it came under attack. Out of those servers we put around the globe, because we just dotted them around the globe, the average time before they came under an attack was 3.5 minutes. So essentially,
Oh.
within 3.5 minutes of putting your server online, people are already trying to probe it and attack it, and and see if they can get in. So that patching problem's just massively massively risk for everybody.
That's right.
Cool. All right, look, I like the idea. I like what this looks like. Let's should we jump to the new architecture, and you can talk us through what that new microservices looks like from your perspective.
So, Travel, you want to basically take us through.
Oh, it's a big thing. Okay. Yeah, so basically what we have here, so if you look at the middle, you have this row that's called microservices. So here we have I call them small microservices or basic microservices. Uh, these actually, most of them are just CRUD microservices, and I insist on most of them. They do handle specific data, like saving the data, validating the data, and everything. These are the basic microservices that we have. And just above those, we have the composites. So you can imagine, in order to do anything in our system, you'd have to hit multiple microservices. It's very common. So, for example, let's say you want to get so you're searching for camper vans. You're a customer online and you are searching for camper vans. To search for camper vans, you have to check a couple of things. First, you have to see what camper vans are available, obviously. You have to retrieve those camper vans, and you also have to calculate the pricing for those camper vans. As it happens, each one of those functionalities sit in a separate microservice. So composite microservices are just orchestrators. Instead of asking the front end, the client, to do this, to send multiple requests and coordinating this, we have like single entry points for those services, and they would go and get whatever they need and return the result to our clients. So all these composite and microservices sit in a ECS cluster, in a Elastic Container Service, and and each of them has a different scale and a different size and different auto scaling rules. So basically, for example, the most important one would have a high memory and high CPU defined for them, but some small ones would just have minimal configuration. And so all of these microservices sit in front of sit behind an ALB, a load balancer, and this load balancer has some routing rules. So it just knows which microservice or composite service to go through as soon as it gets a request. And then we have multiple clients. So here we're defining the B2C portal, which is what Rajesh mentioned, the Brids website, the Maui website, and all of the others. And we also have our own portal, which is used by our partners, our agents, and also by THL's own employees. So these are our two main clients. So also on top of that, we're still talking about the Cosmos platform. We also have so all of these microservices, whenever they save something to the database, they would also send an SNS message to a specific topic, and this SNS can be subscribed to by one or more SQS queues. And then we have several workers. If you look down, these workers are polling those queues all the time, are listening to those queues, and they can do specific actions based on what they receive there. So whenever we have an asynchronous load, we just delegate it to those workers, just so we don't hog the request itself. Just as an example, we have something to record the history of any rental that we have. And obviously, you don't want that happening synchronously while the user is waiting for his rental to be done. So, yeah, so that worker would listen to a rental created SQS message and would record the history of that. So that is on a high level, but we're saving everything to a Mongo database, SQL database. That's we use Mongo Cloud, Mongo Atlas, and that's also hosted in AWS. Yeah, so now we can start with the second part, which is the telematics part. And again, all of these are integrated together. So if you look down on the left where this cute camper van, so these camper vans have devices in them that are sending telematics data all the time. So continuously sending telematics data as they move around, as the engine is turned on, whatever. Okay.
How is that getting to you guys? Is that like a 5G connection or?
Basically Wi-Fi or 5G. It depends on the camper van, I guess.
Okay. So,
Yep,
if it was Wi-Fi, then would that does that mean they have to be connected to somewhere or?
No,
yeah,
so these camperman's got a B2 device, and we've got a basically SIM card, and basically pushes data. So if it's a network, but we're talking about Australia. Australia's got quite a lot bad patch as well. There's no network. So what happens is basically as soon as it comes to network, it starts basically pushing data. So when it's a network, it just keeps pushing every second data.
Right. So as soon
and
as it connects, it dumps as much as
Yeah.
of the
Yeah,
previous
yeah,
data it's got.
yeah,
Gotcha.
yeah.
correct. So that data goes to Kinesis, which then gets to our workers, to our system. The messages are interpreted, and then they are also saved in two places. They are saved in MongoDB, and they are also saved in Elasticsearch. And yeah, when they are saved in Mongo, we send a message back to the device itself to acknowledge that we have received this pack.
So just travel here. So what happens is basically take example campervan which is going on the road, and it's a 50 road and driving on 80 should not happen, but that's what is happening. We get the data here, and then what happens basically we got an event worker which basically says that hey, it basically not qualifying the rule. Rule is validated. We have to basically send notification back to the basically device. So we have to say to customer that hey, you looks like we're driving on overspeeding, slow down. So there's a whole lot of rule is in place. One of the rule is speeding. Other rule could be the geofence. We've got a geofence defined. We receive data and we find that this person is entering into the area, which is in the fire zone, which happened in Australia quite a lot. And so we can basically push them an alert that, don't enter this geofence because there's a fire happening, and so that we can save our customers. So there's a lot of thing happening. Like Australia again, to give example, Australia, a low hanging bridge. There's a lot of bridge which is quite low. So we've got a geofence defined around it. If someone is driving with a camper van, we know that's going to hit the bridge. So we basically alert them that there is you are basically approaching a low hanging bridge. So and so speed in these things again. This is where the whole thing comes in picture. So when something happens, things gets processed. You can't basically respond back to customer after 5 minutes. The speed is a key here. If you basically take 5 minutes to basically respond to customer, he's already under the bridge. So the performance is very important here. It should be 1.5 within 1 second. We're talking about millisecond right now. So and basically, and it's happening. It's live for almost a year now, and that's what it does.
Cool.
If I'm not mistaken, it was also used when there were borders between states in Australia as well.
Yep.
Yep, that's geofencing solution. Yep, so all this data is written to SQL as well. Now, on the bottom right, you can see where our reporting solution happens. So what happened here was there was already a reporting solution running in the old system and the monolithic system that you saw, and we kind of determined that it was too expensive right now, at least for the moment being, to recreate all these repos. So we decided to kind of integrate with that old system as well. We took kind of a hybrid approach. So we said, okay, we have no SQL data coming up all the time, and we need to transform this into SQL data so that the old reporting system can understand that. So the way we did this was we have some triggers on our database. So whenever something is saved to the database, it triggers an event. That event will send the data to Kinesis. Okay, so Kinesis will then send the data to Upsolver, and we are using Upsolver to extract, transform, and load the data. So it's actually transforming the data, flattening it out, and based on the type of the data it's receiving, it actually sends it. So S3 and Amazon Glue are used internally by Absolver actually, but the destination really is Athena. And yeah, and then it goes to our data lake. And then our old reporting solution can use this data and still extract the report as it used to do with the old monolithic application. Granted, we had to do some small changes, but in the gist of it, we were able to use the same reporting solution that we had before.
Cool.
And
All right.
this is, we are referring to hundreds of report which is running out of this data lake.
Yep.
So we got a BI solution there. We got all these SSRS report, and so we got a modern application sitting here. We push things here, and then things gets picked up through ETL, and we continue running those reports.
All right, cool. So I've got some questions, and let's start from the top because I've definitely got some questions around the data lake as well. So at the top there, ALB. So obviously that's replaced your load balancers. At the moment, how do you deal with scalability in regards to that? You know, previously you had to, you had the process where you had to go from 3 to 20, and it was a pretty manual process. Now, what's your process for scaling?
So all these microservices that you can see below have rules defined. They have rules defined that say if memory hits 80%, for example, or CPU hits 80%, then create a new instance before we actually need it. And also all these microservices have different sizes defined, and they have a minimum number of instances and a maximum number of instances just to keep cost under control. So, for example, the rental microservices, which is quite essential, has, I think, maybe at least 5 instances, 5 tasks running all the time. And we can scale it up to 30. So whenever we get the CPU up to 80%, it will create 1 or 2 instances automatically in preparation for the incoming additional requests. And we even had instances where we had to override that maximum instance limit. We went in and changed it to 50, for example, because of a surge of requests. But usually that works quite well, and it also keeps the cost down. Like at night when nobody is requesting anything, it will use just 4 or 5 instances, reducing the costs. And typically during the day, it will increase and go up to 15 or 20. But other microservices like I don't know, like
Pricing.
no, pricing is also
Yeah, busy one.
is
Yeah.
also used a lot. Yeah, that's the highest one actually. But other microservices like comments, for example, or commission, these are
Yes.
very rarely used because they are admin stuff. They are stuff defined by the staff. So these will usually sit at 1 or 2 instances with a low memory footprint.
Okay, so obviously, as those new microservices spin up, they're just going to ALB saying, "Hey, I now exist," and ALB automatically scales. The request comes in, you suddenly get an explosion of requests. ALB it just handles it and scales out, and then just sends it to your new microservices that have spun up, essentially. Yeah.
Yep. So every microservice has a metadata endpoint that we use to tell the ALB and the AWS that, hey, I'm alive. Okay, so that's the way that AWS can know, the ALB can know that this service is alive right now. And so, yeah, in addition to that, when a service dies for any reason, that metadata endpoint will stop returning, okay, so I'm not alive anymore. So
Not
AWS
healthy.
will, yeah, not healthy, exactly. So a new instance will be spun up and will be running.
Okay, and so you got ECS there, which is your container service. So those containers are you running a container per composite or a container per microservice?
So we have a base image that we use for almost everything. And in our deployment process, we have something that will spin up a container whenever it's deploying out of the base image. And yeah, it will be 1 container per task, obviously, but yeah, that's the gist of it.
Okay, great. And obviously then, so patching now just goes back to that base container. You just need to make sure that that's secure.
Exactly. So patching right now means change that base container and then run a script to redeploy everything, which is not a big deal right now because we can deploy everything pretty fast.
So just basically, so you patch the original base container, and then you kick off your script to cycle through everything. So all that
Yep.
they'll just start up again with a new container,
Yeah.
and therefore the patch
Exactly.
environment.
It will recycle all the existing tasks and spin up new tasks that use the new image. And
So
yeah,
what
the
do your
good thing,
patch guys do now then? Because I mean, compared to what you would have had to do previously, compared to now,
well,
that's going to be a lot easier task, right?
I mean, our DevOps guy, they handle
Yeah,
this
they write
entire
this
thing
automation
actually.
script now.
Yep.
Right, so they've
But
moved into that DevOps environment,
That's right.
and I'm curious to that journey, because obviously we have guys out there, right? When I go and talk to customers, like the big banking customers, I talk in front of a lot of these IT guys, and they're all sitting there going, "Oh, hang on a sec, my job's about to go away with this new environment." So tell me about how did you make sure that pain wasn't transferred across to those guys? Did you guys have like a retraining program for the guys to move across,
Yeah,
or what did that look like?
yeah. I think I can take that. So yes, I think there was a lot of concern in the business. I'm not talking about just the IT people. Like any automation you talk about, people just think that their job is going to go away, and so idea is not that. So when you're building such a multi application to microservices, this application is smart today. We basically automated a lot of business process as well, and so we had this problem in every part of the business. Only thing happens is basically talk to them, train them, and redeploy them, and that's and they also feel part of the whole journey. They feel that I'm doing something new, and they can add new value. So, and this is what happened in the IT sector as well. We basically trained them, and all these people now today basically train in AWS, and they basically do things in AWS. So we
Good.
deploy
Yeah,
them.
I think it's important, right? Just to let them know there is a program to get them on board onto the new one. And because IT people, I mean, we're all geeks. We all love technology, right? So we all love learning new stuff. So as long as I feel that as long as we let them know there's a pathway to the new environment, and you're going to be supported on that journey, then yeah, typically the IT team gets behind it. We do have a question here. How do you keep the size of the base image base image low? Wider use cases means larger base.
okay, yeah. So for some of the services, so the base image. Again, the base image is replicated everywhere, but when we're deploying it, we choose the memory size and the CPU size on demand, depending on the services. And again, our IT guys did a great job in automating that as well. In reality, we can write this in the code itself. We have a repository that handles all of this stuff. We can say, okay, the pricing service needs 256 megabytes of memory per instance, for example, with a maximum of 30 instances, and that is handled automatically by the deployment script. Sorry, what was the question again?
What about dependencies? So obviously each of these microservices are going to have different dependencies, and the more dependencies you put into your base image, the bigger that base image is going to be, right? Whereas if you just had a specialist base image for pricing and it only needed a couple of dependencies, that's going to be smaller than having a generic base image with all the dependencies built in
Well,
for all your different
uh,
microservices.
honestly, until now, we didn't have that problem. So our
Yeah.
dependencies are low enough that we don't have that problem right now. In reality, what we had to do was have multiple versions of .NET Core on the base image, but that's okay. So we had some services that were still running on .NET Core 2.2, others that we upgraded to 3.1. Pretty much everything is running on 3.1 right now, save a couple that were a bit hard to handle, let's say. So yeah, so what we did there was just keep the two versions of .NET Core there, but other dependencies are pretty much common for all services. What I have to say here is we have a structure for those microservices. Pretty much all of them use the same structure for everything. So dependencies are more or less the same for all of them. If there's
Okay.
any difference, it's small enough that we don't care enough to create a new base image just for that.
Yeah, you have that option later on, right? If
Yep.
you could spit
You
out
do.
in .NET
Yeah.
cores, for
I
example.
can tell you that is one of those apps. I think one or two of those that actually use a different base image, because
Yep.
we had some problems with the Linux version on that thing for the specific. So we had the servers that had to connect to SQL Server, and that base image, that Linux version that we had on our base image, wasn't able to do that for security reasons. So we had to use a different version of Linux there, and yeah, that was easy enough. Just we had another base image, and they changed the deployment script to actually use that base image when deploying that service.
But it's also
And
One thing I
kind of
missed
like,
out.
sorry, you go.
One thing I missed out is basically all our APIs are in .NET Core. It's written .NET Core, and we run on Linux machines. So we don't run on Microsoft. That's a pretty cool.
Yeah, and also the beauty here is it seems like you've got some pretty good reference architecture for your software, which sort of standardizes the, I guess, the frameworks and design patterns you use, right? And I guess
Yep.
that sort of helps you avoid technical sprawl. So, rather than have to deal with, go back to the 80s and 90s and have DLL hell, you've kind of got some good practices around dependency management, media package management, and so forth.
Yeah. Basically, we have kind of a standardized library that that most microservices use to do everything. And we try to keep the dependency between microservices itself minimal, although at times we fail to do that, but most of the time we're pretty good at doing that.
Got to limit the blast radius, right? Because the whole point is it's cattle, not pet, right? So,
Yeah.
but overall, though, like, I mean, it looks like this is quite an interesting storytelling, right? So you've gone from sort of a business which has had to evolve quite significantly, and then through that, your back-end systems have also had to support that business drive to evolve and adapt and overcome. And so sort of like it looks like as a business comes up with new lines of products or new services to markets, you kind of try and make sure your backend systems support that as well. And so the sort of decoupled microservices approach works quite well. But also along with that, I guess you've got this question around with the monolithic system, people kind of have to work out or know the quirks. So they have to know where to go to find a particular snippet of code. And complexity grows over time, and you get this onion layer of code, which is gradually sort of evolving and becoming its own thing, right? And that sort of leads to this concept of cognitive load on developers, where they have to say, oh man, okay, I've got to go and change this part of the website, and then I've got to go and change that part of my data access layer and so forth. How did you find that sort of burden on developers change as you went from a monolith to sort of loosely coupled architectures?
I think Chaval, you can give you a story. That's a very interesting story what you shared.
I can answer that. I can talk about myself about this one. So again, I joined about 2 years ago, and the app was pretty much half developed, if you want. The architecture was pretty much done already. So when I joined, I thought that I knew what microservices was. Well, for me, microservices was like every module, module of the application is a microservice. So you get what, like 5, 6 microservices. That's it. And now I joined this company, and my first task was to upgrade all the microservices to .NET 3.1. .NET Core 3.1, and there I discovered that we have something like 70, 80 microservices. And I was like, what? How am I going to get what all these things do? That's impossible. And then I asked our QA lead, like, do you really know what all of these does? He told me, yeah, all of them. I was like, okay, I'm going to fail. This is not going to work. But yeah, after 3 or 4 months, once I learned what the product does, I was able to identify. Like, I can say that, okay, this is the name of the microservices, so it's pretty obvious from the name that this does this. Another thing that I think helps, so when somebody new joins, you can actually specialize them in something, at least for the first few months. And microservices kind of help there, because then you just have to give them something like 5, 6 repositories, for example, that handle a specific module. And they don't have to look at all the others, at least at first. And yeah, the quantity of code there is a bit minimal. It's easier to look at than actually looking at a huge app that has hundreds of thousands of lines of code.
And do you find sort of the alignment between your product teams and the microservices approach that allows you to sort of onboard people easier and they can specialize and be more productive in certain areas?
That's right. So I think before we used to hire developer, and that developer is for a product. Now when we hire developer, that product, that developer could just work on pricing stream or scheduling stream, and they're specialized in that area, and that basically makes it really interesting. And sometimes we basically swap people, and so that people specialists on a pricing stream, and they say, okay, I want to work on scheduling streams, and they feel like I'm in completely different new company. So it's a very, very interesting experience.
Yeah, and it's also quite interesting to see that it's like, again, going back to the change aspect of the conversation, right? So business is evolving, systems evolving, but you've got this sort of concept here about any given time anything can change, even right down to the way you persist data and sort of the technologies used to give you an adaptable data structure, right? Like if you look at, say, MongoDB document store, right? So you've gone from relational to object-based documents, data lakes, for example, as opposed to data warehouses by itself. And so do you find these things sort of, do you have any kind of learnings to share around sort of having, I guess, the ability to change quite frequently and how you align technology specifically to help you keep the change going?
Yeah, I think one of the first challenge what we had was we when we started developing, it was .NET Core, and that was basically still in the beta version. And so when we used to get stuck with in the code, there was no help available because the community was not built at that time. So we really struggled at the time in the beginning, and then so the selection of technology. So we were a new team, pretty much like a startup company, and we used to do a lot of things, a lot of places. And so what happened is basically we also realized that we have got a lot of things all over the place. So again, like if you have to basically go back and basically try to redo in a different way, probably will not basically increase our technical footprint that much in the beginning. Try to establish yourself and then start growing gradually rather than pushing all over the place. So I think that's something was interesting in the beginning, and then we basically managed to reduce ourselves and start increasing, start making those incremental change in the business.
So would that be sort of the one thing you'd do differently if you could go back in time?
Definitely, definitely. Yeah, like it just that's something definitely was painful in the beginning. So we just exploded, what we were doing at that time, and we were all over the place. So gradual move will be really, really good moving forward.
Oh, very cool.
We're running out of time, guys, but this is fascinating. So I do have one question to wrap up. What does your CI/CD look like now? Because I know that was one of the benefits you called out. So what does that look like?
Chabal, you take it.
So yeah. So it's pretty standard, to be honest. We have an integration with TeamCity. So anytime you merge to master or you create a branch, you create a pull request, you get the build out of the box, and you get your unit test that run, and we can deploy then directly from TeamCity. So we don't deploy automatically. We never deploy anything automatically because that would be too much to handle. But we get builds ready, and then QA or devs themselves can go and deploy whatever they want directly out of TeamCity. So
what's
yeah.
QA doing now then? Previously they would have a whole do they have a bunch of tools where they go and retest it? Because surely your unit testing is going to do the automate the testing,
Well,
or
unit testing never does everything. That's that's a very nice dream, but but unit testing never does everything you expect it to. There's always some manual testing involved
And
there. But
integration,
yeah, but also they are creating pretty nice automation tests as well. They are creating tests using Cypress, and they are working a lot on that right now, trying to test all our major workflows.
so if I pushed some new code today, when is it going to be in production?
If you push to
today.
master,
Yeah, if I push to master
today.
today,
Today.
okay, all right.
Yeah.
So our rule is once on master, it goes on production directly.
Okay, and then as a dev, if I do my own branch, then and it has to go through the entire testing process, what is how long is that going to be? Is that a day, or is that 24 hours? Is that longer?
It depends on the size of what you did, really, and how many microservices you touched. Usually it is same day, or worst case scenario, one day after, unless there are some problems you find or anything. And again, that's something that microservices is excellent at, because like pretty much all the time you're not touching any microservice that another dev is using at the same time. So QA can have the liberty of testing this particular microservice that you have changed and releasing it, knowing that he's not going to interfere with another person's work, for example.
And how easy is it to roll back if it goes into production and then we find something? How easy is it for you to get back to the previous build?
As long as you didn't do anything destructive, like changing data destructively, that's a click of a button, basically. So
Nice.
we have tags on our build.
Yeah.
You just go and deploy it again.
Yeah, I think one of the main thing what we learned through our structure is basically, part of innovation is basically you have to fail fast. So if something happens, you should be able to go back to where we exactly were. So that's something we learned. And so if something goes wrong, we are back to business again.
Yeah, and you know what? That's the biggest advantage I see from an operation model, is the ability to fail fast and to produce fast and optimize. Right? It's about continuously optimizing. With these microservices, you can make changes, constantly make changes to get the best version of it quickly. Whereas back in the monolithic days, you make a change and it'd be weeks before it went into production where you could see the impact of that change, and then if you had to roll it back, that was painful as well. So people were scared to make changes. Now in this new environment, it's like, right, let's iterate, let's try this, let's see if this improves it, let's try and move faster, right? And I find that as developers, they find that really, really motivating, because they can see what the impact is in essentially real time.
That's right. And I still remember, Trevor, like we had a release cycle every Tuesday night, 10 p.m., because we had to cover Australia, Perth branch. And that's a nightmare. Like it's like, your dinner finished everything, and then you go online and there's a release happening, and then everyone jumping and testing everything. It's a nightmare. Can't even think about it now.
Yeah, it's crazy. Well, listen, guys, this has been really fascinating. We're going to have you back again to talk about some of the operating model changes that you guys did. We might do that as a live event, or we might do that as a Twitch event. We haven't quite decided yet, but we're definitely going to have you back again. So listen, really appreciate you joining us today. I've found it fascinating, and it's certainly opened my eyes. Appreciate it.
Wonderful.
Thanks, Trevor.
It's a pleasure. Thank you.
Excellent.
Thank you.
Cheers, guys.
Thanks,
Cheers.
guys. Bye, guys.